Today we discuss about inner product space. First we going to this definition of inner product space. Definition: an inner product space on a real vector space V is a map an inner product space on a real vector space. On a real vector space V is a map V cross V to R satisfying the following properties. Satisfying the following properties. First one, for xyz belongs to V and alpha belongs to R. For xyz belongs to V and alpha belongs to R. First one, x inner product x greater than equal to 0 and x inner product x equal to 0 if and only if x equal to 0. Number B, x inner product of y equal to y inner product of x for all xy belongs to V. Number C, x plus z y equal to x y plus z y. Again and x y plus z equal to x y plus xz. Okay, and here D, option D, alpha xy equal to alpha xy. These four properties satisfies by one inner real vector space, then we call it an inner product space. Now we give some example of inner product space. So we erase this portion now. Some example of inner product space. We considered V equal to Rn and then x equal to a1 a2 an, or here x1, x2, xn beta. Okay, x equal to this and y equal to y1, y2, dot 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 yn. Then x inner product of y equal to summation I equal to 1 to n xi yi. Okay, then it is an inner product. Then this dot product is denoted by an inner product, and Rn with inner product is called the n-dimensional Euclidean space. The n-dimensional Euclidean space. Okay, so if we check this one, then all properties are satisfied. X greater than equal to 0. If I put x then xi square greater than equal to 0, xi square equal to 0 implies that xi equal to 0, that means all x equal to 0, and xi yi equal to yi xi, and xi z xi yi, and here zi yi, then this one is added, then xi plus zi plus multiplied by yi. Okay, that means all properties are satisfied for an inner product. We check it one. If x, then this one equal to I equal to 1 to n xi square, obviously greater than equal to 0. If x equal to 0, this implies that xi equal to 0 for all I. This implies that x equal to 0, and x equal to 0 also implies this. If you check third property, xy equal to I equal to 1 to n xi yi equal to I equal to 1 to n yi xi equal to yx. And fourth and simple property, xzy equal to I equal to 1 to n xi zi multiplied by yi equal to I equal to 1 to n xi yi plus I equal to 1 to n zi yi equal to xy here and zy here. Okay, next, in similar way we also done this. X y plus z equal to I equal to 1 to n xi yi plus zi. This one equal to I equal to 1 to n xi yi plus I equal to 1 to n xi zi. This one equal to x y plus xz. Okay, so in this way we proved all, and last portion is alpha belongs to R or any real number, then alpha xy equal to summation alpha xi yi I equal to 1 to n equal to alpha summation I equal to 1 to n xi yi equal to alpha xy. This is done. So this satisfies all condition of inner product. So this one is an inner product. Now we proceed further. So erase all this. Now we develop another one, and we further proceed with another one. Now what we handle? We handle simple another inner product example, and this develops inner product all and satisfies all properties of inner product. We see Rn and inner product is of this one is a inner product space. Now we see C01. C01 denote the vector space of all real valued continuous function on 01. The vector space of all real valued continuous function on 01. Okay, all real valued continuous function on 01. Then if g belongs to C01, define inner product of Fg equal to integration 0 to 1 Fj f of ft gt dt. Okay, now we then satisfy all the properties. All properties are trivial because if equal to 0 to 1 f square t dt. F square must be greater than 0 and this must be greater than equal to 0. And obviously f plus g is equal to integration 0 to 1 f plus g multiple t h t dt equal to 0 to 1 f t h t dt plus 0 to 1 gt h t dt. This one equal to fh, this one equal to gh. Okay, and similar way, if g plus h equal to fg plus fh, done. And similar way, if alpha f g equal to alpha of fg, this one is trivial, but we prove on famous. This one is erasable now. This proof in another properties. If this one equal to 0, then f equal to 0, and if f equal to 0, then this one equal to 0. If f equal to 0 or g equal to 0, then this one equal to 0 is simple trivial one. Now proceed. If this equal to 0, if g equal to 0, this implies that 0 to 1 ft gt dt equal to 0. This implies that ft gt dt f is 0. If is 0 implies here f, this implies 0 to 1 f square t dt equal to 0. Okay, f square t dt equal to 0. Now we have to prove that this implies we have to prove that ft equal to 0. How we prove it? We prove it by a simple lemma. We prove it a simple lemma, which lemma shows that if f is a continuous function, then if f equal to if f greater than 0, then lemma, this lemma what shows, this lemma shows that if 0 1 to r be continuous with ft greater than equal to 0, with ft greater than equal to 0 for t belongs to 0 1, for t belongs to 0 1, then integration 0 to 1 ft dt equal to 0, ft dt equal to 0 if and only if t equal to 0 for all t belongs to 0 1, for all t belongs to 0 1. Now if 0, then this one is 0 is trivial part, but we have to prove this part. This part means 0 to 1 ft dt equal to 0. This gives what? This gives this, and we have to show that, to show ft equal to 0 for all t belongs to 0 1. For this cause we have to show that if f greater than, since f greater than 0, f greater than 0 is given, since ft greater than equal to 0 and f is continuous, so if ft greater than equal to 0 and f is continuous, then there exists t0 such that f of t0 greater than 0, f of t0 greater than 0. Let alpha equal to f of t0, let alpha equal to f of t0 and epsilon equal to alpha by 2. For this value of epsilon, for this value of epsilon, by continuity of f, by continuity of f, by continuity of f at t0, by continuity of f at t0, there is a delta, such that ft belongs to alpha by 2 and 3 alpha by 2. Okay, for t belongs to t0 minus delta and t0 plus delta. Okay, then we see that by using various properties of integral, we see that 0 to 1 ft dt greater than equal to t0 minus delta to t0 plus delta f of t dt greater than equal to t0 minus delta plus t0 plus delta alpha by 2 dt equal to alpha delta greater than 0. This contradicts our assumption, so ft equal to 0. Okay, today stop here.